Let's go back to our Chapter 8 handout. So make sure you have access to this handout. It's under Lectures, Chapter 8. Chapter 8 is about radical equations and expressions. Today we'll cover radical expressions, and then on Thursday we'll finish this with radical equations. Radical expressions, since you have that word radical, it basically means expressions that have radical signs. And for our class, we only need to focus on two radical signs. One is the square root, the other one is the cube root. We don't need to worry about other radical signs. Let's fill in the blanks for number 1. The exponent of the variable in any perfect square is always a blank number. So you could look at perfect square. For example, 9 is a perfect square. I could put 9x squared to represent an expression that also is a perfect square, because I could rewrite this as 3x raised to the second power. As you can see, the variable has an even exponent. For all the perfect square expressions, you will always see an even number as the exponent. When you take a square root, you simply divide the exponent by 2. So for example, if I have square root of x to the 6, and if I want to simplify this, you could do it step by step. Rewrite the base as a perfect square. The base as a perfect square, it will be x cubed raised to the second power. This is by the product rule of multiplying exponents raising to a power. So you multiply the power 3 times 2, that gives you 6. Once you rewrite the base, you could cancel out the square root and the square. All we have left is x cubed. So to conclude, all you need to do is simply divide the exponent, the even exponent, by 2, and that's how you simplify square root expressions. Moving on to number 2. The square root of a quotient is the blank of the square root. This is talking about the quotient rule, which is just the quotient. Square root of a quotient is the quotient of the square roots. So for example, square root of 5 over 7 is the same as square root of 5 over square root of 7. Number 3, the square root of a whole number that is not a perfect square is a blank number. If it's not a perfect square, we cannot simplify the radical number, then it will become an irrational number. Like square root of 5 or square root of 7, these two, we cannot simplify them. We cannot get rid of the radical sign, so they are irrational numbers. Number 4, the blank of a non-negative real number a is a number that when squared is a. So this is the definition of square root. What that means is square root of a is a number such that when I square this number, I will get the radicand a. That's what that sentence says. Number 5, the principal square root of 16 written as square root of 16 means the blank of 16. As you can see, the way they wrote it, square root of 16, there is no sign in front of square root of 16, meaning that we will take the positive square root. Any question about number 1 to number 5? To simplify radical expressions, all we need to do is rewrite the radicand as a perfect square multiplied by whatever is left. So your job is to factor the radicand as much as you can, and your goal is to rewrite the radicand as perfect squares. For example, number 1, 5 radical 196. If you're not familiar with the table of perfect square, you should take a look at the table of perfect square. You could construct it yourself, squaring all the natural numbers, 1 square, 2 square, 3 square, 4 square. You go all the way up to probably 30 squared, and that table should be sufficient. You will be able to find out 196 in that table, and the corresponding base is the answer to simplify square root of 196. If you don't have access to the table, you could still do that, and that requires you to construct a tree. So for 196, we could construct a tree. Let's construct a tree. 196, you probably noticed that it's divisible by 4. If you don't know it's divisible by 4, you could also do 2 because it's an even number. If you divide it by 2, then the other number will be, I believe, 98. And then we're going to circle the 2 because 2 is a prime number. We keep doing for 98. We're going to break it into a pair of numbers. 98 is, again, an even number, so you could divide it by 2. And the other number will be 49. Yeah, 49. And then we circle 2. For 49, you probably notice it's a perfect square. So you're going to do as 7 times 7. Circle both of them because both of them are prime numbers. Therefore, we rewrite 196 as its prime factorization, which is 2 times 2 times 7 times 7. So I'm going to rewrite 196 as 2 squared and 7 squared. And then apply the radical formula. When you take a square root of a product, it's the same as taking a square root of each of them. So 5 square root of 2 squared, square root of 7 squared. I basically put those two parts into separate radical signs. And then you could cross out the inverse operations. In this case, it will be the radical sign and the square. So cross out these two because those are perfect squares. And you write down what's left. So we have 5 times 2 times 7. And if you calculate that, it's going to give you 70. And that will be the final answer. This is if you don't know that 196 is 14 squared. If you do know 196 is 14 squared, then you will do a different way, slightly different way, but essentially the same thing. So you will start with the same expression, and then you're going to rewrite 196 as 14 squared. That is if you know that 196 is 14 squared. And then you cross out the inverse operation, square root and the square cancel out. You will have 5 times 14, and that is also 70. Any question about number 1? Make sure you rewrite the base as a perfect square. Very good. Number 2. Most of the expressions that you see in this chapter were not going to be radical numbers. It will be radical expressions where you have variables. And the variables, most likely the exponents are not always going to be even. So you will see odd exponent variables. In that case, we will break the variable into 2 parts. One is the even exponent, the other one is the odd exponent, which we will see plenty examples today. Number 2, simplify each radical expressions. Part A. Part A is very straightforward. We have a radical as the base, and then we have a square outside. So you could immediately cross out those two operations because they're inverse operations. So you just cross them out, and then you write down what's left. So we have 14b cubed left, and that's it. Part B, square root of 169y to the 4th. For this one, I'm going to rewrite the base just like what we did before. 169, if you look at the square, the perfect square table, you will notice it's 13 squared. So you will rewrite that as 13 squared. Y to the 4th, you could break it into 2 parts if you want, or you could rewrite as y squared raised to the 2nd. And then I'm going to put them into separate radical signs. So you have radical 13 squared times radical y squared squared. And notice that all my radicands are perfect squares, so I could cross out with the square root outside. And then you write down what's left. First part is 13, second part y squared. And that simplifies part B. Any question about number 2? So far what we all have perfect square expressions, so there's nothing left in radical signs, but that's not always the case. For example, number 3, we have radical 90y cubed. I would say neither of those two factors are perfect squares. 90 is not a perfect square. Y cubed is not a perfect square. However, the mechanic is still the same. How we do is we break the radicand into a perfect square multiplied by whatever is left. So starting with 90. You probably notice 90 is the same as 9 times 10. And why do I break into 9 times 10? It's because 9 is a perfect square. So that's why I get familiar with that perfect square table. And then let's deal with the variable part. Variable part is y cubed. Y cubed, how do you break into a perfect square? Well, we have y squared, that's a perfect square. So you have to do a y squared. If I have a y squared, what do I need to multiply additionally in order to get y cubed? That's a y. So that's how you break the y cubed into a perfect square multiplied by whatever's left. And then we put them in separate radical signs. So you have radical 9, radical 10, radical y squared, and radical y. For the perfect squares, you could take it out. Radical 9 is 3. And then square root of y squared, that will give you y, because you could cross them out. So I will take that out. As for the other two parts, square root of 10 and square root of y, because these two are irrational numbers, they're not perfect squares, you can't get rid of the radical sign, so you put them together. I will put them back inside as a product, radical 10y. And that will be the final answer to number 3. Any question about number 3? Very good. Number 4 is a radical of a quotient. One of the fill in blank says that the square root of a quotient is the quotient of the square roots. Usually what we do is we simplify the quotient inside first, if we can, and then we take square root of the numerator and the denominator. However, in this case, 32 over 7b to the 6, we cannot simplify it. So we'll go straight to assign them to separate radical signs. We will have radical 32, radical 7b to the 6. And this question simply becomes number 3, but 2 of them. One is for the numerator, the other one is for the denominator. This time I'm going to break right away. Square root of 32, I will break it into square root of 16 times square root of 2. And notice that I already put them in separate radical signs. Square root of 7b to the 6. Square root of 7, we cannot do anything about that, but b to the 6, because it's an even power, you could actually rewrite that as a perfect square. It will be square root of b cubed squared. And by the way, this is only for the beginner. If you already know what the answer is, you probably know that you only need to divide 6 by 2. That's how you get rid of the radical sign. Now let's cross out the inverse operations. You have square root and the square, so that's how you get b to the 3rd. On the top, we have a 4, and then you have radical 2 over. As for the bottom, you have b to the 3rd and radical 7. So what I like to do is I always like to put the numbers, the rational numbers first and the irrational numbers next. That's why I switch the order between b cubed and radical 7. It's just a personal preference. Any question about number 4? All right. Number 5, the expression radical a over pi represents the radius of a circle where a is the area. What is the radius of the circle that has an area of 16 pi square inches? This is giving you the area, asking you what the radius is. So first, let's rewrite the expression as an equation. It says the expression radical a over pi represents the radius, and that means r is radical a over pi. And since they gave you the area, it's 16 pi, so you simply plug it in. Replace a with 16 pi over pi. This is the example where most of the time we will simplify the radicand first, the expression inside first, and then take care of the radical sign. In this case, the quotient you could cancel out with the pi's from the top and the bottom. We have radical 16 left. Radical 16 is simply 4, and that's the radius of the circle. And we could put a unit there, it's 4 inches. And that concludes 8.1. Let's do a practice for 8.1. Let's see. Let's do an easy one first. Starting with number 8. Let's do number 8 first. Give you 2 minutes. Simplify number 8 and then send your answer to the chat. Let me know if you need any help. All right, do you guys finish? So this one is a perfect square. If you simplify, there should be nothing left inside. There should be nothing left inside. Let's see. So I think your answer is right, Maya. I think your original answer is right. Your second answer is not correct. So let's look at this one. First thing to do is rewrite the radicand as perfect squares. 144, if you look at the perfect square table, 144 is actually a perfect square. But if you don't know that, then you could use the tree diagram and you will be able to simplify that as well. Since I know that it's 12 squared, I'm just going to rewrite 144 as 12 squared. Next is x to the 8th. X to the 8th, because the exponent is an even number, you could rewrite that as a perfect square. So that's simply x to the 4th raised to the 2nd power, because 4 times 2 is 8. And the last part is y to the 4th. Again, it has an even exponent. You could rewrite that as a perfect square. Y squared raised to the 2nd power, because 2 times 2 is 4. So that would be the first step. Anthony, I think you forgot your x. Everything else looks good. It's just you forgot your x. And then we're going to cross out inverse operations. First part, you have the radical and the square cancel out. And then you have radical and a square, radical and a square. So that's the whole purpose why I write my radicand as something raised to the second power, so I could cross out the inverse operations. And then you simply put whatever's left together as a product. From left to right, we have 12, we have x to the fourth, we have a y squared, and that will be our final answer. Any question about number 8? Very good. We're gonna look at a more complicated problem, which is let's do an ultimate problem. Let's do number 18. And notice that these are all your homework problems. I basically giving you time to do your homework right now. So number 18, give you 3 minutes, simplify this, and then if you can, type your answer to the chat, because your answer might be a little bit complicated. Let me know if you need help. All right, did you guys finish number 18? So we have one answer provided by John. I would say the answer is partially correct. You're missing something. First of all, you're missing a negative sign. And then second of all, you could actually simplify x to the fifth as well, even though it has an odd exponent, but you could break it down into an even exponent multiplied by whatever's left, and then you could take a square root. So you could actually further simplify your answer from there. Anyone else got an answer for us? So let's look at this one. First of all, it's a quotient, right? It's a quotient, square root of a quotient. Square root of a quotient, the first thing we do is check whether or not we can simplify the quotient. Our quotient is 64x to the 5th y squared over 121. Unfortunately, we cannot simplify this. There's no common factors that we can get rid of. So we go straight to the next step. The next step is the square root of the quotient is the quotient of the square roots. So you distribute that square root to the top and the bottom. This is basically showing you all the step, and this is the first step. And then you keep going. So now this number 18 simply becomes number 8, because we just did number 8, simplify a single radical expression, and we have 2 right now. On the top, I will break it into 64, and you probably know 64 is a perfect square. Next one is x to the 5th. X to the 5th, I will break into x to the 4th and x. So you break it into an even exponent and whatever's left. The biggest even number less than 5 is 4, so that's why you have x to the 4th, and then the remaining will be x, because x to the 4th times x is x to the 5th. The last one is perfect. It's a perfect square, so you just leave it square root of y squared over, actually let me rewrite 64 as a squared, so I could actually cross out inverse operations. For the denominator 121, it's also a perfect square. It's 11 squared. And now we are ready to cross out inverse operations. First part, square root and the square. Second part, x to the 4th, you simply divide it by 2, or actually I can rewrite that as x squared squared. So it's easy for you to see. So you could also cross out the square root and the square. The next one, radical x, we cannot cross out anything because x is not a perfect square. Last one, y squared, you cross out the squares. For the bottom, you also do the same thing. And then we write down what's left. Do not forget the negative sign. It's outside, so you always need that negative sign. On the top, we have 8, and then we have x squared. We have y. Those are the outside ones. And we still have an inside one, which is right here. This is the irrational part. You cannot simplify this. So I usually put that at the end. You have radical x right there. Over the denominator is 11. So this will be your answer to number 18. Any question about number 18? All right, so that's basically how you simplify radical expressions. Hopefully you know how to do that. And if it's an even exponent, you just divide the exponent by 2. That's how you get rid of the radical sign. If it's an odd exponent, you're going to break it down into an even exponent multiplied by whatever's left. And then you take the square root. So make sure you remember that. Now, next section, 8.2, is addition and subtraction of radical expressions. When we add or subtract radical expressions, it's just like how we add or subtract algebraic expressions. You need to make sure they have like terms. In this case, we're not talking about the same variable. We're talking about the same radical part. If they have the same radical part, then we add them. For example, number 1, if we rewrite 2 radical 12 plus 3 radical 75 as 4 radical 3 plus 15 radical 3, then we can combine terms. Originally, it doesn't look like you can combine them because we have different radical parts. You have radical 12, you have radical 75. They are not exactly the same, but we can simplify those radical parts using what we discussed in 8.1 and rewrite the expression as 4 radical 3 plus 15 radical 3. Now they do have the same radical part. Then you could simply combine them. In this case, if you combine them, you simply add the numbers outside. 4 plus 15, that's 19, followed by radical 3. And that will be the answer if you add those two radical numbers. Number 2, radicals that are blank even when simplified cannot be combined. This is talking about unlike radicals. Some of the radicals, even if you simplify them, you cannot combine them because they're not like. So we will see some examples later as well. Number 3, radical expressions that have the same radicand are called like radicals. So the same radical part. If they have exactly the same radical part, including variables, then they are like radicals, and then you could add or subtract them. Number 4, the blank is used to add or subtract like radicals. This is talking about the distributive property. We could use the previous example to illustrate what that means. The previous example is 4 radical 3 plus 15 radical 3. What we did is we take out the common part, which is radical 3, and we add the numbers left. So it's 4 plus 15 times radical 3. And that's the distributive property, but in the reverse direction. And that gives us 19 radical 3. This is also how we combine algebraic expressions. We take out this common variable part, and then we add or subtract the coefficients. Same idea. Let's look at some examples. Practice number 1, radical 2w plus 5 radical 2w. This is a very easy example because, first of all, they do have the same radical part, which is radical 2w. Therefore, we can apply the distributive property, simply add whatever's outside. The first radical expression doesn't have anything outside, so we have an invisible 1. You place the invisible 1 there, and then we could apply the distributive property. It becomes 1 plus 5 multiplied by radical 2w, and that gives us 6 radical 2w. That's number 1. They are already like radicals, so you could combine them. But most of the time, the expression is not going to be like radicals, or not going to appear as like radicals, and you have to simplify them yourself and then combine them. For example, number 2, subtract w radical 45 and w radical 5w squared. So that requires us to simplify because right now they don't have the same radical part. Let's simplify each of them. First one, if it's the number outside, you just copy it. And then radical 45, I will break down into radical 9 times radical 5, because radical 9, we know what that is. It's 3. Minus radical 5w squared. So same thing, we're going to break it down into radical 5. 5 is not a perfect square. That's all we can do. And then w, and then square root of w squared. Because it has an even exponent, I don't need to break it down into even times whatever's left. Next thing to do is simplify, calculate. Square root of 9 is 3, so this part will be 3w. That's the part that's rational, that's outside. And you have radical 5. Minus, over here we have perfect square w squared, so cross out with the square root. You could take out that, and that becomes w, followed by square root of 5. And again, it's just my convention. I like to put the rational part, the number outside first, and the radical numbers the last. After this, we do have 2 like radicals. They have both radical 5. So we can apply distributive property, 3w minus w, followed by radical 5. And you simplify what's 3w minus w, which is 2w, followed by radical 5. And that will be your final answer to number 2. Any question about number 2? All right, moving on to the last practice problem. It's a word problem. They want you to find the diagonal of a rectangle that has a width of 6 inches and a height of radical 18 inches. First, let's graph a rectangle. Let's graph a rectangle. Okay, very good. And then second, we're going to do the diagonal. The diagonal is defined as connecting any two non-adjacent vertices of a rectangle. We have 4 vertices in a rectangle, which are the 4 corners. If you want to connect the non-adjacent ones, they have to be diagonally. Let's connect them. So let's say I'm connecting these two. And this blue line segment is one of the diagonals. And of course, you could connect the other two to give you the other diagonal. Those two diagonals are exactly the same. Now let's label the sides. It says that the width is 6, so I place a 6 right here. And the height is radical 18, so you place radical 18 right here. They want you to find out the diagonal, so I'm going to make the diagonal x and create equation to solve for x. This requires you to apply the Pythagorean theorem, which applies to right triangles. In a right triangle, let's see if I can do a right triangle. Okay, good. In a right triangle, if you have 3 sides, A, B, C, and we know that a squared plus b squared is c squared. So we're going to apply this Pythagorean theorem to create our equations. A squared, that is 6 squared, plus b squared, that is radical 18 squared, equals c squared, which is x squared. So this is our equation. We simplify each side. You have 36 plus square root of 18 and square. So these two cancel out because they're inverse operations. And you have simply 18 equals x squared. 36 plus 18, that's 54. 54 is x squared. We need to further simplify and isolate x. The next inverse operation will be square root because we have x squared. So we're going to take a square root on both sides of the equation. On the right-hand side, since x has to be positive, so you simply write x because x is the length of a diagonal, it must be positive. On the left-hand side, you simply simplify radical 54. I will break down into radical 9 times radical 6 because 9 times 6 is 54 and 9 is a perfect square. And that simplifies to 3 radical 6. So my answer is 3 radical 6 inches for my diagonal. Any question about number 3? Very good. Now let's practice with some of the problems. Let's see, what should we practice? I'm going to give you a couple. Let's practice with number 5, number 6, number 8, and finally number 10. All right, I'll give you 8 minutes. Complete these 4 problems. The instruction says combine and simplify if possible. Let me know if you need any help. And of course, we can do number 16 later. All right, did you guys finish these 4 problems? I would say number 5 and number 6 are pretty easy. The only thing you need to work on is just number 8 and number 10. So let's look at these 4 problems together. Number 5, they cannot be combined because they don't have the same radical part. You have radical 8, you have radical c. They're not unlike, so cannot be combined. And then we have number 6. Number 6, we can combine them. They have the same radical part, radical 2x plus 3. We put an invisible one outside of radical 2x plus 3. Apply distributive property. We have 5 minus 1 times radical 2x plus 3. And that is 4 radical 2x plus 3. Number 8, radical 72 minus radical 18. They do appear unlike, but we can simplify each of them. Radical 72, I will break it down into radical 36 and radical 2, because 36 times 2 is 72, and 36 is a perfect square. Some of you might did 8 times 9, and then you have to further break down a into 4 times 2. You could do that as well. Minus radical 18, so I'm going to break it into radical 9 and radical 2, because 9 times 2 is 18, and 9 is a perfect square. And then you simplify that. Radical 36 is 6, radical 2, minus radical 9 is 3, radical 2. And then you apply the distributive property, 6 minus 3, that is 3, followed by a radical 2. So you get 3 radical 2 for number 8. Number 10. Radical 20x cubed minus radical 5x. Same thing. Break down radical 20 into radical 4, radical 5. And then break down radical x cubed into radical x squared and radical x minus radical 5, radical x. And then we're going to simplify this. Radical 4 is 2. Radical x squared, you have inverse operations. You could cross it out. Followed by radical 5x minus. So those two things is also radical 5x. I actually don't need to break them down, but I'm just showing you the first step. General first step is just break down the radicands. And then I put an invisible one outside. And now they have like radical parts. I can combine them. Apply distributive property. It's simply, so I think I forgot x right here. So you did simply 2x minus 1 outside, and then you have a radical part of 5x. And that would be the answer to number 10. Any question about these 4 problems? So let's look at number 16 because Bella wants us to do number 16. Let's look at number 16. It's x radical 81 xy cubed minus y radical 64 x to the 5th and y. This is indeed pretty complicated. First thing to do is simplify each of them to check whether or not they have like radical parts. Chances are they do. First part, x radical x1 radical x. As for the y cubed, because it has an odd power, we will break it down into an even power and multiply by what's left. The highest even number less than 3 is 2, so you have y squared with a leftover of y. So this is how I break down the first part. And then you do the same thing for the second part. Square root of 64. And next part is square root of x to the 5th. Again, 5 is an odd number. We will break down into an even exponent multiplied by whatever's left. The greatest even number less than 5 is 4. So you're going to write it as x to the 4th multiplied by radical x and radical y. So that will be the first step. You rewrite the radicands. All right, and then we're going to simplify this. So starting with the first part, you have x times radical x1 is 9. Let me actually switch these two orders. So I put 9 first, and then you have x, and then you have inverse operations right here. Inside we have x, and then the y squared will become y, so it takes outside, and you have a radical y, so it goes inside. That will be the first part, 9xy radical xy minus, so we're going to do the same thing. Y stays outside. Actually, leave more space. Y stays outside. Radical 64, that's 8. And then radical x to the 4th, that's x squared. And then followed by radical x and radical y, so that's radical xy. And now we are ready to combine these two because they have like radical parts. Apply distributive property. You put what's left outside together. So you have 9xy minus 8x squared y, followed by radical xy. And that's already good enough. If you want to factor a common factor, you can. You could factor out xy between the two numbers outside, but it's optional. So that would be the final answer to number 16. Any question? All right, very good. So we're going to move on to the last section that we're going to cover today, which is 8.3. 8.3 is multiplication and division of radical expressions. So we have covered simplifying radical expressions, adding and subtracting radical expressions, and now we're going to work on the last two operations, which is multiplying and dividing radical expressions. All right, let's fill in the blanks first. To multiply two radical expressions that are blank, we use the rule that radical A times radical B equals radical AB. So this is talking about two radical expressions that are different from one another. Number 2, so here we have this is basically what we used before, right? When we simplify our radical expressions, instead of putting them in under separate radical signs, so we put them together. Number 2, to blank the denominator of an expression means to rewrite the expression in an equivalent form that contains no radical in its denominator. This is talking about the process of rationalization. So to rationalize the denominator of an expression means to rewrite the expression in an equivalent form that contains no radical in its denominator. And then we will look at some examples today as well. Number 3, the quotient rule of radicals, radical A over radical B is radical A over B, where A is greater than or equal to 0, B greater than 0, allows us to bring the radicals under a single radical sign. This is also like the inverse of what we did earlier when we simplify radical expressions. Number 4, the key to multiplying radical expressions that contain more than one term is to use the distributive property. Number 1, multiplying and simplify. So we have radical 11x times radical 33y times radical 3xy. The way I like to do it is I like to regroup the numbers in my expression, put all the numerical parts together, put all the variable parts together, and Ideally, you also want to separate the variable parts based on the variable. So first, put the numerical parts together. We have radical 11, we have radical 33, and we have radical 3. So put them together. And then we have variable x, so I put them together. We have 2x, so that's x squared. And finally, we have variable y, so that's y squared. For the first numerical part, I will break 33 into 11 times 3. If you break down 33 into 11 times 3, the first part can be even nice looking. You have 11 squared, and then let's put them in separate radical signs, and 3 squared. Followed by, actually, we could simplify that already. So cross out the square root and the square root and the square, you have xy right here. And the numerical part, they're also perfect squares, so cross them out. Multiply them, so that's 33 xy. Any question about number 1? Any question about number 1? So that's how you multiply radical expressions. Usually I put the numerical part first and the variable part second. Moving on to number 2. Find the quotient and simplify. So it's the same idea. I like to separate them and then simplify. So let's put them first. We will start with putting the quotient. We have 2 separate radical parts. I'm going to combine them as 1. So apply one of the formulas in the fill in the blanks. You have 20x cubed on the top and then 80x to the 7th on the bottom. And then we simplify this. 20 and 80, they have a common factor of 20. So you cross out both of them and then you write a 4 next to 80. As for the variable part, you apply the quotient rule. X to the 3rd and x to the 7th, you have a higher power downstairs. So you could cross out the x cubed on the top. And then you cross out the 7, write down the difference between 3 and 7, which is 4. So let's do it step by step. I'm going to write down what's left right now after I cross out common factors. On the top, there's nothing left, which is simply 1. So you have a 1 on the top. As for the denominator, it's 4x to the 4th. So this is what happens after we simplify the quotient. Once we simplify the quotient, you could take a square root of both the top and the bottom. Square root of 1 over, and then for the denominator, I'm going to do square root of 4, square root of x to the 4th. And then you simplify. Square root of 1 is simply 1. Square root of 4 is 2. Square root of x to the 4th is x squared. And that is the answer to number 2. And it does look very nice. After we simplify, it becomes a perfect square. All right. The next 2 practice problems are talking about the rationalization of radical expressions. So remember, from fill in the blanks, rationalization means that the expression is in an equivalent form that contains no radicals in its denominator. Starting with number 3, we have a radical part in the denominator, which is radical 3. So we need to get rid of that. In order to get rid of that, you apply equivalent fractions. If you remember, if I have a radical number and multiply by itself, it's going to get rid of the radical part. Like right here, we have this radical 3. In order to get rid of this radical 3, you simply multiply radical 3 by itself. Radical 3 times radical 3, that will give you radical 9, which is 3. And that's how you get rid of the radical part. Since we cannot change the value of the expression, you have to do the same thing to the numerator. On the top, we're also going to multiply by radical 3. And then we multiply straight across. On the top, you have to be careful because we have 2 terms on the top. So we have to distribute radical 3 right there. I put an invisible parentheses there, and then you could distribute radical 3 inside. Let's multiply. Denominator becomes 3, and the numerator you distribute, so that's 7 times radical 3. It's just 7 radical 3, minus radical 2 times radical 3, that's radical 6. And that will be the final answer to number 3. We completed the rationalization process. Our equivalent expression doesn't have any radicals in the denominator. Number 4 is a little bit tricky. We have a minus radical 5 in the denominator. Some people might say, what if I multiply both the top and bottom by the radical part itself? The radical part is radical 5. If I multiply both the top and bottom by radical 5, you will still have radical part in the denominator because I have to distribute this radical 5 to a and radical 5. So that doesn't help. What we're going to do is we're going to use, which is right here, the conjugate of the denominator. The conjugate of the denominator defined as, you use the same numbers first. We have two numbers, 8 and radical 5. So you use the same number, a and radical 5. Instead of having a minus sign in the middle, you use the opposite sign. The opposite of minus is plus, so you're going to do a plus radical 5 as the factor that you're going to multiply to the denominator. Since we cannot change the expression of the radical expression, we need to do the same thing to the numerator. So on the top, you also have a plus radical 5. This is what it means by conjugate. Same number, different signs in the middle. That's the conjugate. And why do we use conjugate? Because we have a formula that says if you have a minus b times a plus b, it will be simplified to a squared minus b squared. That is the formula that we have been using for the entire semester. If we multiply a minus radical 5 and a plus radical 5, we can use this formula, and you will see what happens after you apply the formula. A squared minus b squared, so that would be 8 squared minus radical 5 squared. That's what's going to happen after you multiply the denominators. And then for the numerator, you have to distribute 3 into a and radical 5. That will give us 24 plus 3 radical 5. So that's the first step, and let's calculate that. The numerator we cannot simplify because they are unlike, so you just copy. Denominator a squared, that's 64, minus radical 5 squared. You cross out the radical and the square, that simply becomes 5. 64 minus 5, that is 59. And numerator, again, we cannot simplify this, you just copy. But as you can see, we successfully rationalized this rational expression. There's no radical left in the denominator. Any question about number 3 and number 4? The rationalization of radical expressions. So two situations. One is if you only have radical by itself, you just multiply the radical number by itself, top and bottom. If you have a constant along with a radical number with a sign in between, then you have to use the conjugate like we did in number 4. All right, very good. Moving on to last page that we're going to cover today, we have a word problem number 5. It says find the area of a triangle with base 2 radical 21 and height 5 radical 7. This does require you to know the formula for the area of a triangle. If you remember from your geometry class, area of a triangle is base times height and divided by 2. So we're going to use this formula, plug in the numbers. They give you the base, they give you the height. So you simply plug it in. Base is 2 radical 21, height 5 radical 7, divided by 2. And let's further simplify this. At this point, I can cross out the 2's because they're the common factors, and then you have products on the top and the bottom. So we simply have radical 21 times 5 radical 7. The next step I'm going to do is put the 5 in the front and then combine the radical numbers. You have radical 21 times radical 7. And for radical 21, I'm going to rewrite that as 3 times 7. And then you have that radical 7 together. So now you could see that I have a perfect square inside. If you want to see all the steps, you could also do this. So you have 5 times radical 3 times radical 7 squared. You could cross out the square root and the square and write down your final answer. It's simply 5 times 7 followed by radical 3, and that is 35 radical 3 feet squared. So that concludes the word problem right here. And again, it's just another computation problem of radical numbers. Nothing surprising. Any question? So for today's attendance, let's do one of the problems, which is number 16 right here. Let's actually do number 16. So this will be the last problem that we're going to practice today. You're going to simplify this radical expression. Make sure you rationalize at the end. What that means is make sure that the denominator doesn't have any radical numbers. I'll give you 2 minutes. Let me know if you have any question about this problem. And then we will check your answer in 2 minutes. The answer is not that, but your answer is close. Your answer is close. You're just missing something. Yes, you're missing square root of 6 somewhere. All right, so let's look at number 16 together. First thing to do is apply the radical, one of the formulas. You distribute the radical to the top and then bottom. So we have radical x to the 6 over radical 6. For the numerator, radical x to the 6, you simply divide the exponent by 2, or you could rewrite the radicand. It's up to you. So that's going to give you x cubed. Denominator, 6 is not a perfect square, so you have to leave it as radical 6. But as you know, this is not a This is not rationalized. We need to rationalize this expression. The denominator has that radical part, so we need to multiply both the top and the bottom by the radical part itself. The denominator will become 6, and the numerator is simply x cubed radical 6. And that's your final answer to number 16. Any question about number 16? All right, if you don't have any question, take a picture and then post in our attendance channel for today's attendance. I already made the post there. And then once you made the attendance post, you're free to leave. Enjoy the rest of your day. Don't forget that you need to submit your chapter 7 homework today. Any question?
Hey, Professor, I have a question.
Yes.
In the beginning of the my Wi-Fi is real spotty here. So I heard you going over the class sessions.
Yes.
What was that again?
Class session? What do you mean?
The schedule.
Oh, the schedule. So I have 2 sessions that I marked with question mark because
Okay.
we're pretty good right now in terms of everything we need to cover. Those 2 question marks that you see right now, we might not need to meet. That's what I meant.
Okay. Yeah,
Yes.
I caught like every third word of it.
So it will just become like a Q&A session. If you need help, we could schedule. Otherwise, we're not going to meet on those days.
Okay.
Yeah, but I will let you guys know in the future. All
right, and then as soon as I update the attendance, I can cut out.
Yes, that's right.
I appreciate it, and stay safe.
You too.
Thank you. Bye-bye.
Bye.